Okay, so today we're going to learn Docker. This tutorial is by Jake. I forgot his last name, but it's very basic and it's a very great tutorial about Docker. So let's get started. Let's watch this video.
In an isolated environment. It gives you advantages similar to running your application inside a virtual machine. Some of those advantages are your app always runs in exactly the same environment, so you don't get inconsistencies in how it behaves. If it works on your computer, it works on every computer, it works on the live server, it always acts the same. If you're working on multiple projects, it lets you sandbox each one and keep them separate, good for security, and eliminates potential conflicts between different projects. And lastly, it makes it easier to get going with somebody else's projects. You don't have to install all of the tools and dependencies that the project needs. You just spin up the virtual machine, put your code inside, and it works. Docker gives you these advantages, but without the overhead and hassle of running and managing a virtual machine. Instead, we have containers. The code and the environment are all wrapped up inside a container, but a container is not a full virtual machine. When you run a virtual machine, each machine gets its own full operating system, including the kernel. The kernel is like the core of the operating system, the bit that controls the low-level stuff. And this is quite resource-heavy on the host machine, the computer running the virtual machines. Containers, however, they all use the host machine's kernel. That core bit of the operating system is shared. But everything on top of that is still separated, everything that makes a Linux distribution unique, because all Linux distributions, Ubuntu, Debian, etc. are all built on the same kernel. And Docker uses special features of the Unix file system to create these isolated environments. So a container is a compromise. The separation and sandboxing is not quite as extreme, but it's enough, and as a result, a container can start up in seconds as opposed to minutes. They use fewer resources too, taking up less disk space and using less memory. So a container is a running instance of an image. An image is a template for creating the environment you want. It's a snapshot of the system at a particular time. So it's got the operating system, the software, the application code, all bundled up in a file. And images are defined using a Dockerfile. A Dockerfile is just a text file with a list of steps to perform to create that image. For example, you'd configure the operating system, install the software you need, copy the project files into the right places, etc. So you write a Dockerfile, then you build that and you get an image, which you can then run to get containers. So let's try out this whole process. First, you're going to want to install Docker for Mac or for Windows. Links are in the description. This is just some software to allow Docker containers to run on your computer. And unless you've got a specific reason to use it, ignore Docker Toolbox. That's the older way to run Docker on a Mac or PC. I've created a new folder just on my desktop for this.
Okay, so let's pause here a bit. So I actually download Docker for Macs, and I think it's running at the moment. Docker.
Demonstration. And I'm going to write a super simple Hello World application in PHP. It's literally just going to echo Hello World. And I'm going to save that in a folder called src for source as index.php. Right now you can't execute that file, you need a web server. Our goal is to use Docker to create one. So let's make a new file and we're going to call this Dockerfile.
Okay, so we're going to create a source file. Inside we have say PHP, and inside it say hello. Let's just say hi to make it simple, and we have a file called Dockerfile with a capital. Let's watch.
We're going to save it next to the source folder, not inside. Dockerfile, capital D, one word. And in here we're going to use code to configure our environment. So for this we want an operating system with PHP and Apache installed. Apache is the web server software. The cool thing though is we don't have to start from scratch. We start in our Dockerfile with the name of an existing image, an image that has already been built. And then we build on top of that. Conveniently you can find lots of existing images on the Docker hub. So if you go to hub.docker.com, sign up, the search doesn't seem to work if you're logged out. You can search into the best ones to look at. We just want like the latest version of PHP, and
so we're going to use this one, PHP 7 with Apache, and
we want Apache as well. So all the way to the end where.
So I fast forward a bit. You can watch the video. I will include the links in the video descriptions, and you can watch it later on.
These are the ones. The first one I defined into there, and you can see it means this PHP image.
So basically, what it's doing is, okay, we in Dockerfile let's do it. So basically, what we're doing is we say we want these images from Docker Hubs. So we're using PHP 7.0, and then web server is Apache. And so you can see all the Docker command is capitalized. And we say we want to do a copy. We copy the source. And this is the source they talk about. So they basically want to copy your local source directory to whatever inside the machine, and they're using Debian, so the web server directory looks like this. And we copy src. So the / is important because we copy all the content inside it. If you put it here, it will copy the source file to this directory, which is not what we wanted. So it's the / is important. So we say var www.html, and then we expose port 18. We save it. Let's look at it.
You run the image and you get a container. That container will listen on port 80. By default, it would just ignore all income to the tag names. And we see it's based on Debian. Similarly, that Debian image will have its own Docker file, and they'll stack on top of each other, like I said earlier. And this layering of images is a huge advantage of using Docker. The PHP's Docker file is a little bit more complicated than ours, but let's just focus on ours for now. So when we build our Docker file, Docker's going to listen on port to tell it the location. The first time you do this, it'll have to download direct. And I'm going to type docker build -t to give it a name. I'm just going to call it hello world. And then
okay, so this is the first command, and I don't think the Docker command is running. So let's open up again. Application Docker. We're studying here at the moment. Yeah, so you can sign up an account and then you push your images to the Docker Hubs. So it's running. Let's get out here. Jack. Okay, so it's running. And so here's the first Docker commands. It say Docker, and then we build -t, what exact -t is. Docker -t. I think it's called tab or something. Configure. What about man Docker? No, -t. And Docker build. No. Docker build -t. Okay, so there's a tab, so lamp or optional tab in the lamp tab format. Set the target build stage. So it's a tag. So basically, for the Docker's running, you need to get the apps running. And what version we're talking about? So 17.06. So let's do it.
Then at the end you want to tell it the location of the Dockerfile. Now since it's in the current directory, we just want to put a dot to say that. Oops, helps if I save the Dockerfile first. The first time you do this, it'll have to download.
Okay, so the command is Docker in 12 minutes. So we do Docker, and if you look at the Dockerfile as well, so we build, then we tab, hello world, and then the location is here. So you can see here we are getting the image, which is PHP-Apache. This is step 1, and step 2 is basically copy the file, and what happened? Get questions I can turn now. What happened? Hub. It's actually quite slow. Yeah, it's quite slow. Maybe I should restart the internet. Okay, let's start the internet. Okay, so I forgot I'm running the YouTube. Basically, I'm uploading the YouTube video before, and now I stopped it. It's much faster now. You can see here it's downloading different layer of the OS.
That make up that PHP image. Shouldn't take too long. Once it's got the image, it's going to copy our files inside. At the end, it outputs our new image, and it's going to be called Hello World. So we can run this by typing docker run hello world. There's one other thing we need in the middle of this. We need to use the -p tag to forward a port 80 from the host to port 80 in the container. So that means that when a request gets to the host is your computer. When a request gets there, Docker's going to forward that to the container. And when it gets to the container, that expose line that we've got in the Dockerfile, that will let the container accept the request and allow Apache to handle it. So we can run that, we'll get some output.
So basically this command is doing is we run Docker and then we set a port. The first one is the internal Docker ports, which means it's running on 18.18, and this is the outside port, which is your machine is running your Mac. And then that's the name of the Docker images. And you can see here we finished the first one, and then we have a hash, and then we copy the file, and then we have another hash. We move in the new container. Yeah. So what it actually means is in order to build something, it has the kind of middle container. It's a build blah blah blah. Docker. What's the command? Docker build, Docker run, Docker. Okay, Docker ps psr. Docker images. So you can see two different images. One is the PHP one, because it's that kind of layer. So you just store inside your machine. It's the hello world. ID. So we do Docker run p18.18 hello world repository. Hello something and driver file programs on Docker error response from the driver file programming external connectivity on endpoint. I think because I have Nginx running. Nginx. Nginx. Stop. How can I start Nginx first? Auto stop. If that's the case, maybe I could do is maybe run on POP81. Not working. Let's move manager.
I'm going to go to a terminal, give it a name, whoops helps image, it's going to copy hello, so that means Dockerfile. We can go, if you go back to index version of the document, this is our request. The request gets the tag to forward.
Let's figure out this error response, driver fail connectivity. Point for fail. Hang on a second. Like this. Okay, so the first part is actually your machine, and this guy is actually the inside the container. Okay, I understand now. So if I do one, so yeah, okay, now I get it.
Port 80 from the, so we can our need to read one to persist between files -v, and we will control containers during development as a host, and we'll see hello world. So we've done it. We've got our application running inside a Docker container. Now, if you go back to index.php and you change this, when you refresh localhost, it won't change. The Docker container won't reflect the new version of the file. And this is because when we built the image, it made a copy of that file. To see the change, you'd need to rebuild the image and spin up a new container from the updated image. During development, this is obviously a massive pain, and this is where volumes come in. So there are two types of volumes. One to persist and share data between containers. We only have one container. I'm not going to talk about this today. But the second type lets you share folders between the host and the container. You can mount a local directory on your computer as a volume inside the container. Then the container, when it's running, will be able to see the files that we're working on. Hit Ctrl-C to stop this container. To mount a volume, we're going to add another option to the Docker run command. We're going to add -v, and we want to tell it to mount the folder users/jake/desktop. It needs to be the full path, not a relative one, /docker /src. So we want that folder, that local folder, to be mounted, put a colon, inside the container at /var/www/html. So the image, it copies this folder to this location inside the container, but during development, we don't just want to copy, we want to see that folder. We want a live view of that folder. So we...
Okay, so let's stop the Docker instance. Let's clean up. So basically what you try to say is instead of copy the file, well, maybe we still copy the file, but we use the -v volume. So we basically mount the source directory, which is this guy. So we mount whatever content here and to whatever inside the Docker instance. And here's tells me, okay, the first thing is always your machine, your actual machine, and this is always for your Docker instance. So we do docker run port 81 because I have Nginx running on port 18. So on my machine I have to use 81, and then whether inside is still at port 18. So we do a -v and we do a full path. See, / is important because we want the content, not the directory, inside or mounted to www.html, and hello world is the instance, and the it's not sure. You can configure share path from Docker preference server. Okay, so we need to share it. Interesting. Preference. Oh, the file sharing. This channel can be mounted. Okay, so we to add something here. Probably not this one. Go to www No. www HTML dash 2. I wonder, can I just do bunch stuff? It's waiting. So slow. And let's see, is it working? It's not working. So it's doing. Can be okay. What about I delete this one and then use this one, because the path. Okay, I think I know how. So it's very interesting because the Mac is using private, and so instead they're not using the var, but instead they're using private. Let's see what happened. Now it's running. So oh my god, it's Mac, and so it's running. So still say hi, and I want to change it Docker so that's good.
You can mount it at that directory built individually, but you can in these code down or augment that tag, and we ended up questions. Feel free to ask any questions. I'll try to answer as many as possible.
So I think that's all for today.